Why do some processes go from one way and not the other? Why does tea spread in hot water? Why do our bodies degrade over time? Why does ice melt? These are some questions that can be explained with one concept: entropy. We know that everything in the universe is disorganized. It is its natural state, not because it wants to, but because there are many possibilities to be in a disorganized state than in an organized state. For example, we can take a book and put it on a bookshelf. This is one organized state. Or we can take the book and put it over the table, a chair, or over my head. There are infinite disorganized states. These disorganized states of the universe explain our second law of thermodynamics. Any spontaneous process increases the disorder of the universe. If a process does not increase the disorder of the universe, then work must be involved. But this is an impossible achievement. Think of this. If I eat lunch, my body will break it down into smaller nutrients, like carbs, lipids, and proteins. These molecules will be broken down even further and will give me the energy needed to organize my room. But part of this energy will go to my heart, my lungs, or even to a muscle that might result in an involuntary movement. Not only that, but some of this energy will be lost as heat. So even though I organize my room, I still disorganize other systems, and my lunch particles will be all over the place. The measurement of this disorganization is what we call entropy. Entropy is a state function. It does not depend on the path the reaction took to achieve its final state. Keeping in mind this entropy definition, which will have a higher entropy, a glass of water or a glass of ice? The glass of water will have a higher entropy, even though it looks organized. This is because the water molecules are able to move freely. So what does entropy really mean? We know that in molecules, energy is stored in its bond, and this individual independent energy storage are called quanta. The more energy a substance has, the hotter it is. But there are many ways the energy can be distributed. These are called microstates. So we can define entropy as the probabilities in which these microstates will occur. And we know that some microstates are more probable than others. Low entropy equals concentrated quanta. High entropy equals spread quanta. We know that the microstates with the most spread out quanta will have more energy. This is what the second law of thermodynamics is trying to explain. Spread quanta is statistically more likable, and spontaneous processes are thermodynamically capable of occurring with the input of heat and are independent of time. It is important to mention Gibbs free energy, the energy available to do work. The more energy available it has, the more likely it is of occurring spontaneously. This and the second law of thermodynamics explains why ice melts in a spontaneous way, but the environment around it does not get hotter. If energy has the chance to expand, it will do so and will disorganize the current state of things.